All right, so we're going to go through a first example here of a rocket problem. The question says, for an object thrown at 40 degrees to the horizontal with a speed of 20 meters per second, draw the graphs of. So here's our picture. We're going to have an object that is thrown. It's thrown at an angle of 40 degrees, and it's traveling at 20 meters per second. The first thing we're going to need to do is find our initial velocity in the x and our initial velocity in the y, because we break things up into their x and y components when they're moving in two directions. So to do that, we know this angle here, we know my hypotenuse. I'm going to use sine and cosine to find x and y. So first, almost always is find x and y initial velocities. So the cosine of theta equals adjacent, which is ux, over my hypotenuse, which is u total. I'm going to solve for ux, so I'm going to multiply each side by u total. And I get ux equals my initial velocity times the cosine of, in this case, 40 degrees. Or theta, when we plug in numbers, it's just going to be 20 times the cosine of 40. And that's going to give me an answer of 15.3 meters per second. Same thing for the y direction. For the y, it's going to be sine theta equals initial velocity in the y over my initial velocity. Following the same pattern, y is going to equal total times the sine of theta. And when I plug my numbers into that, we're going to get a value of 12.9 meters per second. All right, so if we look at these two numbers, these should make sense, right? Again, this is my x, this is my y. We have an angle that's less than 40. So I should have a greater value in the x and a smaller value in the y. If this was 45, they should be equal. X is 15.3, y is 12.9. They're kind of close, but x is bigger. So boom, that's good. All right, once we have that, then we can go through our checklist of things we need to find. So the first thing, find the horizontal velocity or draw a graph of the horizontal velocity versus time. So if we do that, A is going to look like this, right? So this is my displacement, velocity, excuse me. Velocity in the x over time. And what we'll see is that that is going to stay a constant value, right? And this value right here is going to be the 15.3. And because x motion, as this flies through the air, right, my motion in the x direction stays constant. My motion in the y direction is accelerated. So that's what the velocity versus time graph would look like for the x motion. Now, let's do the same thing. B is going to do the same thing, but now for the y motion. So because y is accelerated, so here's my time, here's my velocity in the y. Here's what we know, right? So let's just draw this. So it starts here, shooting upwards with a velocity of 12.9. Each second then, its velocity is going to change because we're going to have an acceleration downwards the entire time due to gravity. So that's my acceleration downwards. And so what I should see is that my velocity is going to decrease on the way down, and it's going to increase on the way up. This is going to be the top right here. That's where my velocity in the y is 0. And then we're transferring back to negative velocities here. So my velocity going up is going to get smaller, smaller, smaller. It's going to reach 0, and then it's going to get bigger, 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 going down. We could figure out specific numbers if we wanted to. Obviously, this value is the 12.9. We could figure out the time to reach the top by understanding that this is my initial velocity in the y. This would be my final velocity in the y. We know my acceleration is negative 9.81 or negative 10, and we could solve for time if we wanted to, using velocity equals initial plus acceleration times time, and getting the idea that time is equal to final minus, minus initial divided by acceleration. And that's how I would find this value there. And then if it reaches the bottom, we're going to know that this value here is going to be negative 12.9. Okay. The last part then says the acceleration versus time. So my acceleration versus time. So if we look at that, so let's just kind of redraw these over here. I'm going to do acceleration separate for x and y. But if we think about this as my velocity in the x versus time, my velocity in the y versus time, and then underneath those, we could say we can have our acceleration in the x and acceleration in the y. So here's what we get. This was our velocity graph. So our acceleration graph is going to be 0. This is a slope of 0. And so there's no acceleration. And so that's why my graph down here would have just a horizontal flat line on the x-axis. For my y motion then, I have this. We should figure out that my slope is going to equal gravity, which is negative 9.81 in this case. And so my acceleration time graph should look like this. And this value would be at negative 9.81. So that's how I would relate those. Again, the slope of my velocity graphs tell me what my acceleration should be. 0 slope, 0 acceleration, negative constant slope, negative constant acceleration.